Hello friends, today I'm going to solve LeetCode problem number 1351, count negative numbers in a sorted matrix. So here we are given an m by n matrix grid and it's sorted in non-increasing order, both row wise and column wise, and we need to return the number of negative numbers in the matrix. Okay, so what does non-increasing mean? Non-increasing doesn't mean it is descending order. So non-increasing would mean like if we have a value 4, the next value could be less than 4, so that could be 3, or it could be a value equals to 3 as well. Okay, so it's non-increasing, right, which means 3 is not greater than 4, right? And again this 3 is not greater than 4, so any next value is not greater than the previous value. That's non-increasing. And for it to be now we know that it's non-increasing, we need to now find the negative numbers. Okay, and it's non-increasing row wise and column wise. Okay, so let's suppose this is one of our rows. Now we have two columns. Okay, let's suppose we have two columns, then it's non-increasing column wise as well, which means that the next value in the column will also be less than 4. So what could the values be? Less than 4 could be 2. Okay, so I'm just going to write 2, and it's non-increasing column wise and row wise as well. So the next value now here should be less than 3 and should also be less than 2. So what could that value be? We could have a value 1, right? Similarly now here next element should be less than 3 and less than 1, so we could have a 0, or like we could have any negative values. So this is how our matrix will be like. Now we need to find the number of negative numbers, right? So if you would just look at this, the least smallest number will be at the very bottom right corner of the matrix, right? As we saw here, like the bottom right corner is smaller than all of the other elements in the matrix. So that is where we are going to start our matrix operation from. Okay, so let's take this matrix here and let's try to solve this. Okay, so this is an example of matrix which has a non-increasing value row wise and column wise. Okay, so every value in a row is decreasing from the previous value, as you could see, and every value column wise is also decreasing, as you could see here. So the least value is at our bottom right. Okay, so we are going to start from here and then we check this value. Is this value greater than or equals to 0? No, right? So we will now increment our count by 1. Okay, next what are we going to do is we are going to traverse column wise. Okay, we could traverse row wise as well, but like we are going to traverse over the column. So now I'm going to check this value. This is also less than is a negative number, so I add a 1. This is again a negative number, so now I add a 1 here to my count. Again I move on to the next value and that's again a negative number, so I add plus 1 again. Next, now I am done with this column. Now I move to the next column, the previous column. So I am now checking this value which is negative, so I add a plus 1 here. Now I again check this value, it's negative again, so I add plus 1. Now here when I encounter this value, it's positive, right? Positive value means now any value that I encounter before this are going to be positive, right? So I don't have to actually check the rest of the values here. So I'm just going to stop right here and then I'm going to move on to now next column. So I'm going to check this one and I add a plus 1 here. Now I check this value and it's positive, so I just stop right there because this value will be the least among all the rows and column values here, right? So I just stop right there because I don't have to go further. So next, now I check with the next column and I get a negative, so I add a plus 1, and then now I add all of these values and get the value of count. So initially our count value will be equals to 0. So our final answer would be 1 2 3 4 5 6 7 8. So that would be equals to 8. Okay, so that is how we are going to solve. So now let's see how we will write our code. So what we're going to do is we are going to take the value of m and n. M is equals to the length of rows. Okay, so rows, and n will be equals to the columns. Okay, and next we are going to loop. So we are starting from the end, okay, and we are going column wise. We are moving over each of the rows, right? So we start our external for loop will be starting from m minus 1 until zeros. Okay, so we'll move from m minus 1 to 0. So here this is a square bracket, which means it's inclusive, and every time we are decreasing the value in each step. Okay, because we are moving one column previous, right? And within this loop we are going to check for each of the rows, each of the value of the like within the row, right? Within the column we are going to check each of the row value. Okay, so I take this column, the last column, and in this column now I'm iterating over each of the rows, right? And I'm starting from the last row here. So n minus 0 1 2 0 row, and I'm decreasing the value of rows. Okay, because this is row number 0 and this is row number 3. So I'm starting from 3 and I'm going to 0. So I'm basically decreasing the value of rows, and also similar for the column, I'm starting from 3 and going to the 0th column. So that is why I'm doing a subtraction here, subtracting by 1. So that is how we are going to perform our iteration. Now let's start coding. So okay, let us define the value of m equals to grid length, and n is equals to grid 0 length. So this is our row, this is our column, the number of columns. Now let us define the count value, which will be equals to 0 initially. Now in our for loop, let I is equals to, so we are starting from the column, so m n minus 1, last column, I is greater than equals to 0, I minus minus. Okay, and then within that for loop we need to iterate over each of the row, right? So m minus 1 j should be greater than equals to 0, and j minus minus. We are decreasing the rows every time. Now if it is not negative, then we do not proceed, right? We just stop right there. So we are going to check that if the grid value at index ji is greater than equals to 0, we just break out of the loop, out of our internal loop, and then if not, we are just going to increase our count, because that would mean that it's a negative number. So in that case we increase our count, and finally we are going to return our count here. Okay, tu. Alright, now let's try to run our code. Awesome, let's submit this. So talking about the time complexity, it's O of n times n, m times n time complexity, because like we have m number of rows and number of columns, and we are iterating over each of the rows and columns. So like worst case would be m times n if all of the rows and all of the columns have negative values. Okay, and the space complexity is constant here. So that's all about this problem. Let me know if you have any feedback, any comments in the comments down below. Hope you liked it. Thank you.